Hi everyone, this is Darren here, and today I'm going to teach you more about how we can factorize algebraic equations using these three identities. So I covered these three identities in other videos, but if you have forgotten, maybe you can just refer to them since I've written them down. So I'm going to refer to this identity as the first identity, the second identity, and the third identity later on when I'm going to cover the examples. And now, before I start off the examples, I'd like to point out some important factors, some important things that we should take note. You see that in these two identities, right, the result is that we get three terms. And in the third identity, we get two terms. So this will come into play later. When we have a question with three terms, we're going to be talking about generally the first two identities. And when there's a question with two terms, we're going to talk about the third identity. And then one more thing, look at the positive and negative signs for this. They are all positive. And this one, it's a positive, negative, positive. Again, later on when our questions, with our questions, you can see that if there are three positive terms, likely we're going to use this first identity. And there's a positive, negative, positive, we're likely going to use the second identity. Okay, so can we use this identity to solve and factorize every equation out there? The answer is simply no, because we can only use these identities to factorize for something if it is truly in one of these three patterns. Because in factorization, we're simply going from one of these three patterns. If we use these identities, we're going from one of these three patterns back here. So we're going to have to go from here to here, or here from here to here, or from here to here. So we're factorizing going backwards. Because this is expanding, this is factorizing. Expanding, factorizing. Okay. So now that I've said that we can't always use these identities, what other ways can we use to solve those questions? So if you can't use identities to factorize, you can also use the cross method and the quadratic formula. But I won't be covering these two in this video, because that will make this video way too long. Okay, so now I'm going to go start off with my first example. So in the first example, suppose we had x squared plus 2xy plus y squared. It's actually quite simple, because why? It's really, you can straight away see, right, this is actually like a squared plus 2ab plus b squared. The a is just x and the b is just y. It's actually very similar, but suppose you aren't able to recognize this, right? What you can observe is that there are three terms. So as I said, if there are three terms and we want to factorize, it's going to be either the first identity or the second identity. And now, to be more specific, there are three positive terms. So therefore, it's most likely going to be the first identity. Hence, you can actually use the first identity and apply it here and see whether you get the correct factorization by backtesting later. So now, when you factorize, right, one trick I like to mention is that you can actually ignore this second term. Because why? This is a squared plus 2ab plus b squared, right? If indeed your identity is correct, it's going to be as such. So what you can use to identify the a and the b, just look at the first term and the third term. You just need to square root this first term, square root the third term, and you'll be able to get your a and a b. So now, I just square root this, I get x, square root that, I get y. So I'm just going to put x plus y and try and see whether they are correct. So now, how I'm going to test whether this is the correct factorization? I'm just going to expand again. Suppose I expand this on my workings elsewhere. I realize that yes, this will indeed be the same. So therefore, I know that my factorization is correct. Take note that these steps here, please do not show in your exercises in your exams. What you have to do is, do this on the side note in the margins as part of your workings, okay? This is just to backtest. These two steps are just to backtest to make sure that your factorization is correct. So actually, when you factorize, you can just stop here. A one-step working is fine, because examiners will know that you're just using the algebraic identities. Okay, let me move on. Something more complicated. but nevertheless still using the identities to factorize. So let's say we are faced with this p square plus 10 pq plus 25 q square. Again, 3 terms, 3 positive terms, right? Therefore, this would make us inclined to, let's try to test out the first identity. So again, as I said, when we want to find out what's our a and our b, we just look at the first term and the third term. As square root p square, I know I get a p. As square root 25q square, I know I get 5q. So I put this as our a, I put this as our b, let's square it. Okay, maybe you want to do working elsewhere or on your own at home, it's fine. You can actually go and test whether this indeed expands to this. So I have done it previously and I know that this is indeed correct. So I won't go about expanding here to save on time. So therefore, hence, this you can just express this as your answer and you would have gotten this question correct. So third example now. Suppose we had c square minus 8cd plus 16d square. Now, how? Slightly different, right? We have this positive, negative, positive. It's no longer 3 positive. So therefore, likely we won't be using the first identity anymore. So what? Second identity or third identity? Yes, the second identity. Because the third identity gives us a result of 2 terms. Here we have 3 terms. So we know the second identity is just a minus b square. Therefore, I'm just going to write something and leave 2 blanks here. It's going to be our a and our b and square. And what are our a and our b? How can we get it? Again, it's going to be similar to the previous 2 examples. We're just going to focus on the first term here and the third term here. Therefore, you square root c square, you get c as your a. Square root 16d square, you're going to get 4d as your b. You write these 2 in, and then you expand it elsewhere in your working. Realize that yes, I have actually factorized it correctly, and hence this is our final answer. Okay. Now, let's move on to a fourth example. Okay, suppose you have a square minus 22ab plus 121b square. Okay, so again 3 terms, positive, negative, positive. Straight away you should be able to get the thing that we are going to use again, the second identity. Hence, again, a minus b square. What is our a, what's our b? You look at the first and third term once again. A square, you just square it, you get a. 121b square, you square it, you get, okay, this is a bit tricky. But if you recall your 11 times table, you'll know that 11 times 11 gives us 121. Hence, you square this, you just get 11b. Therefore, our a is just a and our b is 11b. Right? So therefore, this will be our final answer. We have used the second identity to solve this, to factorize this question also. So now, okay, we've done 4 examples, 2 positive, 2 negative. 2 first identity and 2 second identity. I'm now going to move on to how we can use the third identity with 2 more examples. So now, this is our 5th identity. Our 5th example. So, suppose we had this 9m square minus 100. Okay. See? 2 terms. So, yes, we're going to use our third identity here. Now, in our third identity, we know that recall the final resultant answer is what it was a square minus b square, right? And we know that this a square minus b square is equals to a plus b, a minus b. Okay? So right now here they're giving us the a square and b square. And then we have to just change it to this form. So what's our a, what's our b? This is slightly tricky. Okay? So what you have to do is you have to again square root just these 2. So you square root 9m square, you will get 3m. because 3m times 3m gives us 9m squared. Therefore I know it's 3m. Okay. And of course 100, you square it, you just get 10, right? So therefore we use the identity as a plus b, because our b is our 10, and then and then a minus b, which will be, our a here is 3m and our b is 10, so 3m minus 10. Hence this is our final answer. Again, of course, you can check. Actually, it's ideal that you check, because it will actually further strengthen your confidence and your understanding of these identities and how we apply them. So if you check, you realize that this indeed will give us this. So we have factorized it once again correctly. Okay, for my last and final example, I'm going to make it slightly more tricky. I like to do this because I think it's good where in the last example we step things up, make it more advanced. So suppose now we have x minus 1 square minus 4. How do we do this? It's a bit different, right? It's not as obvious as the results of the 3 identities. There are 3 terms, but now there's a square here. I don't know. Maybe you want to pause and think about it by yourself. Okay, so suppose that, thought about it, do you realize that the trick here is you can actually treat this whole thing here as one term, and this as another term. So some of you, if you treated it as 3 terms, would be wrong in this case, because you can actually treat this as just one term. So this one term, and then it'll just be 2 terms. Because why? What happens when you treat it as 2 terms? You see, 4 can be square rooted, correct? So now, if I rewrite it like as such, maybe it'll be more obvious to you. See, if I rewrote this 4 as 2 square, right? Maybe it's more obvious to you. Isn't it a square minus b square? Yes, it's as simple as that. So this, we actually should, for a question like this, we should actually use the third identity. Therefore, we're going to say this is our a and this is our b. Therefore, a plus b, a minus b, what would it give us? A is just x minus 1 now. A plus b. Okay, now a is our x minus 1 still. So a minus b, so minus 2. Therefore, do we leave it like this and say this is our final answer? In this case, no. Because we can actually simplify these 2 terms here, right? We can simplify these 2 numbers and make it smaller and neater. So what we should do is just say minus 1 plus 2, it gives us positive 1, so x plus 1. And here, minus 1 minus 2 is going to give us minus 3, so x minus 3. And now, we know that this will be our final answer. So this, we can present this as our final answer. And okay, we are done with this tricky question. So I hope that you enjoyed this video and you learned something. And if you still have questions, of course, please feel free to put your comments below. I hope that you really enjoyed this video, and please like and subscribe. Thank you very much.